Today we're going to have a look at what happens if we change something in our trig graph. So we've looked at the basic shape of the trig graphs, so the sine graph, the cosine graph and the tan graph. Today we're going to look at what happens if we change things slightly, okay? I'm going to show you this using Desmos. You can get this just on the internet, it's completely free. It lets you type in graphs and see what the graph of any function looks like, which can be really quite useful. Okay, so the first one I'm going to look at is the graph of y equals sine x. We recap. The graph y equals sine x starts at 0. It starts down here at 0, goes up to 1 at 90, back down to 0 at 180, down to minus 1 to 70, and back up to 0 at 360. It would then continue on forever. So the maximum value is 1, minimum value is minus 1. The period of the graph is 360, because at 360 it repeats itself. What I want to look at is what happens if we put a number in front of the sine x. So if we look at y equals 2 sine x, for example, I want you to have a wee look at the graph and I want you to have a think about what's changed and what stayed the same. Now I'm hoping we've noticed that instead of having a maximum value of 1, it now goes up to 2, and similarly it goes down to minus 2. Period of the graph hasn't changed. Where the maximum value occurs hasn't changed, it's still at 90. Where the minimum value occurs hasn't changed, it's still at 270, and it still repeats itself every 360 degrees. Okay. Now before I click the button, have we think what you think y equals 4 sine x would look like. I'm hoping there you were thinking that's going to go up to 4 down to minus 4. So that's absolutely perfect. It is. It's this line here, green one at the top, so it's going up to 4, down to minus 4, still repeating itself after 360. So the period of the graph hasn't changed. The only thing that's changed is the maximum and minimum value. Okay. Have we think about the next one then? We're going to look at y equals minus 3 sine x. Any ideas? Okay. The graph of y equals minus 3 sine x. The 3 still becomes our maximum minimum value. So maximum value is still 3, minimum value is minus 3, but it flips the graph upside down. So it almost reflects the graph in the y-axis. Okay, so if it's a minus number, instead of sine starting by going up, it starts by going down. Now, it doesn't matter what number I put in the front of there, it's still going to do the same thing. The only thing it's going to change is your maximum and minimum value. I'm going to take the ones in sine x away, so I can show you cos x. Okay, a reminder then, there's our graph y equals cos x, starts at 1, crosses down through 90, down to minus 1, back up to 0, and finishes back at 1 at 360, and again it's then going to repeat itself. What do you think the graph of y equals 5 cos x is going to look like? Very similar to the sine graph then. It starts looking like a really nice cos graph now with the going up to 5. Starts at 5, goes down, turns at minus 5, back up and stops again at 5. So again, the only thing that has changed here are your maximum and minimum values. Your points where it crosses the axes have stayed the same. Your points where your maximum and minimum values are stayed the same. The period of the graph stayed the same. The only difference is your maximum and minimum values. Y equals a half cos x. Same idea again, doesn't matter it's a number less than 1 or not less than 1, that's a bad analogy there, but a number between 0 and 1. It's still then going to be just changing your maximum and minimum values. So it goes up to a half, down to minus a half. Everything else stays the same. Negative 1, and that's why I couldn't say a number less than 1 before, and I really needed a number between 0 and 1. Negative, same idea as before, and negative 2 cos x, turns it upside down, reflects it in the axis, again doesn't change where it crosses, doesn't change what the maximum and minimum value are, it's still 2, it just flips it upside down. Okay, now sine x, cos x, very similar. We're going to have a look at tan. There's our graph of tan. Tan graph's a bit strange. No maximum, no minimum. period this time of 180, it starts repeating itself again here. You'll see this part of the graph here is the exact same as the first part of the graph from 180 onwards. If we look at y equals 2 tan x, let's actually click the button, you won't see much of a difference. You see a slight difference in the scale, okay? It squidges it in more. But if I change my settings here and I change my values of my y-axis, because I've got them just set up to 6 and minus 6, if I make this minus 60 and 60, you see there's really not much difference in these graphs at all, because there's no maximum minimum value, and because every tan graph is going to get closer and closer and closer to those lines at 90 and 270, it actually doesn't make that much of a difference. So you won't really get asked about ones like 2 tan x, 3 tan x, because it doesn't change the maximum minimum value, because tan doesn't have a maximum minimum value. So ones like this, we really are concentrating just on sine and cos. Okay, I'm going to go back to your notes now, and we can fill in some of the questions about graphs then. So we are looking at graphs of the form a sine x and a cos x. If we have a graph a sine x, that means it goes up to a and down to minus a. So we have maximum value a, minimum value a. Same with cos. The period of the graph hasn't changed, it still remains the same. Okay, so this wee part is in your notes just as a wee summary of what this looks like. A couple of things we'll get asked to do with this. We'll get asked to write down the equation of the graphs, and we'll get asked to draw the graphs. So we're going to try these just now. Now this might be tricky. First part, straightforward enough. First thing we need to do is decide whether we have a sine graph or a cosine graph. And we know that by looking at where it starts. If it starts at 0, it's a sine graph. Starts at 0, goes up, round, down, sine graph. Cosine graph starts there. If you imagine it on its side and flipped, if that looks more like an S, that looks more like a C. Okay, so this graph then, it goes up to 3, it goes down to minus 3. It's a sine graph because it's starting at 0, so that must be the graph y equals 3 sine x. Cos graph this time, it starts at the top rather than at 0, goes down to the bottom down here and back up again. It's going up to a quarter, down to minus a quarter, so that must have equation y equals a quarter. Cos x. Now the tricky part. So much easier on a board or pen and paper than it is using this graphics tablet. I'll give it a go. Okay, we need to draw the graph of y equals 5 cos x. So that's got a maximum value of 5, a minimum value of minus 5. It's going to stop back at 360 and it's going to start up here at the top. So it's got a maximum value of 5, minimum value of minus 5. I've already got my 90, 180, 270 and 360 marked on. So I need to start here at 5. I need to cross here at 90 by 180 into down at minus 5, 270 back at 0, 360 back up at 5. And remember, and curve it as much as possible. It's not a straight line, it is a curve. So there is my graph of y equals 5 cos x. And this explains why I'm showing you these on decimal, so not just relying on my drawings. Okay, second one, we want to draw y equals minus sine x. Okay, so minus sine x have a maximum of 1, minimum of minus 1. It's a minus sine x, so that means it's upside down. So that means instead of starting going up to 1, it starts by going down to minus 1, back to 180, up to 1, back to 0. So it's going to go down. Oh, that was bad. Let's try that again. So it's going to go down here, turn, up, round, and turn. So that's y equals minus sine x degrees. Okay, I'll leave you to practice some naming and some drawing graphs then. As ever, please contact me if you've got any problems at all. More than happy to spend time going over more questions with you.